In this lecture, we present how to handle various input devices connected to the Raspberry Pi board using Python language. Some sensors require importing of the additional libraries that implement communication protocols, as in example DHT temperature and humidity sensor. Simple sensors, like in example button, use binary or analog values to present their state, so we can use them straight. A push button is an electromechanical sensor that connects or disconnects to point in a circuit when the force is applied. Button outputs discrete value either high or low. A microswitch, also called a miniature snap action switch, is an electromechanical sensor that requires a very little physical force and uses tipping point mechanism. Microswitch has 3 pins, 2 of which are connected by default. When the pressure is applied, the first connection breaks and one of the pins is connected to the third one. The most common use of a push button is as an input device. Both force solutions can be used as simple objects, detectors, or as an AND switches in the industrial devices. Here we present a solution where push button is connected to the GPIO4. To work properly, the GPIO4 must be configured as a digital input. Pressing the push button connects the GPIO4 pin to the board mass. On Raspberry Pi, GPIO pins are normally pulled up to 3.3 volt when the button is pressed, and GPIO4 is read using GPIO.input, it will return the false result. Each GPIO pin can be configured to use an internal pull-up or pull-down resistor. Using a GPIO pin as an input, these resistors can be configured using the optional pull-up-down parameter in the GPIO.setup function. And this parameter is omitted, resistors will not be activated. In this case, the input may be floating, giving unpredictable results during reading. If the GPIO pin is set to GPIO.PUD up, the pull-up resistor is enabled. If it is set to GPIO.PUD down, the pull-down resistor is enabled. The motion detector is a sensor that detects moving objects, usually people. Motion detectors use different technologies like passive infrared sensors, microwaves, and Doppler effect, video cameras, and previously mentioned ultrasonic and IR sensors. Passive infrared sensors are the simplest motion detectors that sense people through detecting infrared radiation that is emitted through their skin. When the motion is detected, the output of a motion sensor is a digital high or low signal. The short name for this kind of sensors is PIR. Motion sensors are usually for security purposes, automated light and door systems. As an example, in IoT, the PIR motion sensor can be used to detect motion in security systems of a house or any building. The laboratory testbed for Raspberry Pi board uses the HC-SR501 infrared motion detection sensor. As previously, we use GPIO4 to connect the sensor to the RPI board. A humidity sensor is a sensor which detects the amount of water or water vapor in the environment. The most common principle of the air humidity sensor is the change of capacitance or resistance of materials which absorb the moisture from the environment. Soil humidity sensors measure the resistance between the two electrodes. A resistance between electrodes is influenced by soluble salts and water amount in the soil. The output of the humidity sensor is usually an analog single value. Example IoT applications are monitoring of humidor, greenhouse temperature and humidity, agricultural environment, but also monitoring critical air conditions in an art gallery or museum. A similar way to the previous examples, we use GPIO4 to connect the sensor to our RPI. This sensor uses more complex communication protocol, and there is a number of Python libraries enabling their use, similar to those written in C++ for Arduino boards. Shell commands to install Python's humidity sensor library for RPI. Enter the following command at the shell prompt to download the library. Change directory. Now install the necessary tools. Then install the library. Here is an example Python code that handles reading from the sensor.